Hello, everybody. Let's talk about absolute value functions real quick. Okay. So, um, let's see, let's try this color, whatever it is. Um, okay, so your absolute value function might be something like y equals the absolute value of x plus 2 minus 3. Okay. Or you know what we could do? We could just, instead of saying y, we could wait for it. You could say f of x or g of x or q of x or whatever. Okay, and that's function notation, but it's going to basically give us the same thing. Okay, so maybe this is our function right here. And we can mess around with that by hand. And we can say, hey, when x is, I don't know, 1, what's y? Or in other words, what's f of x? Well, let's see, if we plug 1 in for x, we're going to get absolute value of 3 minus 3, which is 3 minus 3, which is 0. Oh, so when x is 1, y is 0, or f of x is 0. And, we could do one more. How about 2? So if we plug in 2 for x, then we're going to get absolute value of 4, and then minus 3 is 4 minus 3, which is 1. Okay. And um, and so just like any other function, you can plug numbers in for x. That's definitely not unique to absolute value functions, as you should already know because we've already covered linear functions. Okay, so what about um, let's see. What else can we talk about? Let's see how that looks on the calculator. Okay. So if I go to the y equals menu, and then I go, math, right arrow. And that's not the only way to get there, but I'm doing it this way. And then option one is ABS, absolute value. Then I can go x plus 2. And now the next thing I want to do is minus 3. But if I just say minus 3, that's not my function down below that I wrote down originally. Now the minus 3 is inside the absolute value bars, and that's going to make a big difference. So instead of just typing minus 3, I'm going to hit the right arrow, boop, right there, and you can see it turn, I don't know, red or something. I'm quite colorblind. Um, but I do have a driver's license. They let me drive. I don't know why. And then minus 3. Now it looks just like the function I originally wrote down, and therefore I've written it correctly. Okay. And then over here, it kind of gives us some information. It says, hey, there's the function screen, there's the graph screen, there's the table, input output table screen. Okay, so let's take a look at the input output table. Notice right here it says table in blue, so we're going to go blue and then table. Hey, some of that looks kind of familiar. Remember once upon a time, about 2 minutes ago, I plugged in 1 for x and we got 0 for y. And I plugged in 2 for x and we got 1 for y. Well, ain't that just special? And of course, I can use the up and down arrows to, kind of explore things that way. And I can go the other way, blah, blah, blah. And everything is super cool and wonderful. And all your hopes and dreams come true. Okay. Um, okay, let's take a look at the graph. Now, as you're undoubtedly aware, when you graph an absolute value function, you always get a graph of a sharp pointed V that opens up or one that opens down. Okay, either way, depending on the function. Well, we don't have that here, but maybe it's because all we're seeing, maybe it comes down off screen, off camera, and then it pops back up or something like that. Okay, that's probably what it is. That should be. Let's go back. Let's go to the zoom button. Option 6 takes us to the standard viewing window. So let's hit 6. And oh my stars, would you look at that? Okay, so now we can explicitly see that sharp pointed V. Okay, so we got that, and it's just super cool. Alrighty. Now, Um, what about the domain and the range of the function? Okay. Well, the domain is all the x values that are getting used. Well, this x value of -9, it's getting used right there. Okay. This point right here uses or has an x value of -9. How about 1, 2, 3, 4, 5? How about 6 right here? Okay, 6 in the domain. Does 6 get used? Yeah, right here. There's a point that has an x coordinate of 6. And since it just keeps going further and further to the right and further to the left, it uses all x values. And that'll be the case even if it opens down. Okay? So for absolute value functions, like, pretty much all linear functions, the domain is everything, negative infinity to infinity. And that's why. Now, what about the range? Well, the range is not which x values get used. The range is which y values get used. Okay, so if I look at y equals 2, is that in the range? Yeah, there's a point right here with a y coordinate of 2. And there's one over here as well. And so that gets used. How about -2? Does that get used? Yep, there's a point right here that has a y coordinate of -2. How about -9? Does that get used? Nope. Okay. The function does not come down that low. So -9 is not in the range. So, for these absolute value functions, the range is never going to be negative infinity to infinity. Okay. So what would it be? Well, how far down does it go? Well, one thing that, let me change colors because it's fun. The vertex right here, that sharp point, it's at -2 and -3. I know, you're like, whoa, whoa, this is a +2. Well, you just do the opposite of the x coordinate. That's how it works. So it comes all the way down to a height of -3, which means the smallest y value that gets used is -3. So it's gonna use up everything from -3 on up. So our range is going to be everything from -3 on up to infinity. Ye ah. Okay. So that's the range. Just like any other function, is the range is all the y values that are getting used. Okay. Now let me, we can. There's some cool things the calculator offers to help us with that. For example, we could go back to the table and say, okay, how small do the y values, or well, just look at the y values in blue, and you say, well, it looks like they just keep getting bigger and bigger. Okay, so yeah, I get that whole infinity thing for the range. Okay, how small do they get? Okay, whoops. Oh, they were getting smaller there, and then they stopped getting smaller. They were, it was getting smaller down to 0, smaller down to -1, smaller, smaller, and then it started getting bigger, and it was like, oh, so it looks like, yeah, about -3 is about as small as it's going to go. That's about as small as we'll get on our range, on our y values. Okay. So you can use the table to help you look around and explore the domain and the range. Another thing on the graph, back to the graph, is, and this is really handy for domain, domain and range, is you can go second trace to the calc menu. I don't know why they call it that, but whatever. And you can use either minimum or maximum. Okay, so let's see. So we know that this point right here, the vertex, that's the bottom of the graph. So we know the range is going to start there and go up to infinity. But, what height is that? Well, it's the bottom of the graph. It is the minimum point of the graph. So we're going to choose minimum. Okay. Oh, if it was the top of the graph, we'd choose maximum, but not the case this time. So we'll go minimum. And then we jump into Monty Python mode, and it says, answer these questions 3. What is your left bound? Okay. Well, we're interested in this point right here. Okay. So let's go to the left of that point. I'm using my left arrow in that circle of arrows on the calculator, and I hit enter. And when I hit enter, it says, what is your right bound? Now, I just had to put the cursor to the left, anywhere to the left, further to the left, closer to the left, whatever. So now I'm going to go to the right of it, and yeah, that looks good right there, I guess. Then it says, what is your best guess? Okay, you can just hit enter, or you can try to put it on the thing, but the calculator is now going to look for the lowest point on the function in between these two markers. It will not look outside those two markers. Okay, so when we hit enter, boop. Okay, now when you do minimum and maximum, the calculator sometimes gets it perfect, but often it gets it super close. And you and I are smarter than the calculator. So we have to say negative 1.99999. Okay, the calculator meant negative 2. Negative 2.99999. Okay, the calculator meant negative 3. All right, and we have to make that leap to help the calculator out. And if you're not comfortable with that, okay, well, that's okay. We could just do it again. We could just say, all right, let's go alpha trace, minimum, and then let's just pick a different combination of our left bound, I'll go further away, and our right bound, and our best guess, right there, I guess. Okay, and then, oh, I got to do some erasing because this is kind of hard to read. Okay. Well, we got the same y that time, but we got a different x. But still, it's homing in on negative 2. And so you can do that if you need to. Okay. But the point is, for finding the domain, you can say, okay, now I know the lowest point. The lowest point on the graph is at height negative 3, so it's going to be from negative 3 on up, and that's my range. Okay. All right. So, a lot of important stuff there. Okay, a lot of important stuff. So, feel free to practice and mess around with it. Okie dokie, artichoke. So, let's go to, whoops, I guess I don't want that there. Oh, and then, that's right, I have to go boop, like that, and then it'll update these things. Nah, that's not real important, but it's fun. Okay. So what if we have something like, if we have a function, we're going to shift gears just a little and say, let's do an inequality. So what if we have f of x is, or well, let's say y, and that'll be fine. Okay, what if we have y is greater than, I don't know, how about the absolute value of 2x minus 1, I guess. All right. So, what does that look like? Okay, now, just like in other, when we did absolute values before for just linear functions, so basically the same thing except no absolute values, um, we, um, we saw how to do this on the calculator. Okay, we're just going to do that right now. So we're going to go math, right, enter, and then I'll type in the 2x minus 1, and isn't that just wonderful? Okay, so if we go graph, okay, we got that. So obviously it's a new graph, and that's super cool. And the question is, um, you know, because it's an inequality, it's not an equal sign. When it's an equal sign, the answer is just the line. But when it's an inequality, it's a shaded interval or region. Okay. So the question is our solution set above the graph? Okay, because notice these are the points that are above the V, or is our solution set below the graph? Well, we just read it and say, it says we're looking for y values that are greater, okay, greater than the graph of the function. Greater, that's up here, okay? So that's where we're going to shade. But it gets cooler than that. You can tell the calculator, hey, I'm going to use the left arrow, and I'm going to hit enter. if you have the old black and white calculator, you'll just hit enter over and over until you get to what you want. I'll hit the down arrow, and instead of just graphing a line, I can hit the right arrow and say, and it gives me this new triangular symbol. See, I had the line, now I got that triangle. That means shade above the line, which is what we want. If I hit the right arrow again, I get that. That means shade below the line. And then there's other things you can mess around with. Pick different things, and then hit the graph button and, see what they do. Okay, so I'm going to go down to OK. I'll hit enter. And now when I hit graph, something wonderful happens. There we go. And it shades it above. And now I feel very fulfilled emotionally, spiritually, academically, ecumenically. So, and that's what it is. Now, you might be saying to yourself, Mr. Borman forgot one important thing. No, I didn't, although sometimes I do. Okay. Um, Mr. Borman forgot that because this is just greater than, there's no or equal sign here, that the line itself, the V itself, is not part of the solution set. Because the statement here says, hey, we're interested in points that are above the line, not equal to it. So we have to do dotted line here. Okay, now the calculator will do dotted lines, but it's kind of a pain in the butt. So, am I allowed to say butt on this video? Okay. Anyway, it's kind of a pain. So, I just find it easier just to do it myself. Okay, or imagine it on the calculator. Okay. But because there's no, oh, I said but again. Because there's no or equal sign here, we get the shaded line. Okay. Now, if it had been or equal, then the only difference would be this. There. Now it's a solid line, and that's what we get with the or equal. Okay? So, what if we change the greater than sign to a less than sign? Okay? What do you think? Well, yes, I agree. Boy, this feels like Blue's Clues. Okay. Um, we would come over here and we would say, now we say less than. So we got a shade below. Okay, and we get this beautiful thing. We get the opposite solution, the opposite region. Okay. Anyway, that is just kind of, how it's done, and it's super cool. And I hope you all have a wonderful day. Bye bye.